Example 3, a force of 16 pounds is required to hold a 40-pound lawnmower on an incline. What angle does the incline make with the horizontal? So it's another ramp question. And they drew the picture for you. I really don't like that picture, so I'm going to try and redraw it. This time they want to know the angle, so we're trying to find out this angle right here. You've got an object on this ramp, and it's 40 pounds. It's a 40-pound lawnmower. And so let's think about the force of gravity is pulling down. 40 pounds pulling down. And then you've also got the force of the plane pulling perpendicular to that plane. And that's the ramp. I don't know what that force is, but I don't really need to know that force. But that's the force of the ramp. And so really the way I look at it is like this. Okay? I see a dog walker problem where I've got two different forces acting on that object, that lawnmower. And so you ought to be able to come up with the resultant force. The resultant force is going to look something like this. Okay? But they kind of just told me what the resultant force was. They said a force of 16 pounds is required to hold a 40-pound lawnmower. So they're giving me the equilibrium. They're saying they need 16 pounds. So this must be 16. Now, again, I know there's a negative in there somewhere, but that negative is just talking about the direction. So if it takes 16 pounds of force to hold it, it must be coming down to the 16 pounds of force. Okay? The red and the blue, that's 16 pounds, is just opposite directions. And so if you know that this is a right triangle, look at this right triangle. Okay, look at this right triangle. And notice how we have one of the legs and the hypotenuse. Okay? So I guess what you would need to understand that this angle is going to be theta right here. And so we've seen an example, and so we kind of just know that it's going to be so. I mean, I guess otherwise, if you wanted to prove it geometrically, if you didn't know that that was theta, you'd have to say, here's a right angle. Okay? So there are two different triangles that both have right angles. And then whatever this angle is, let's call this angle alpha. I don't know. When you look at this triangle, it has angles theta, a right angle, and alpha. Theta, right angle, alpha. And then when you look at this triangle, it should have the same thing. Okay? I've got an alpha, I've got a right angle, this other missing angle has to be theta. So that's how we're proving that geometrically. But anyway, notice your angle theta, and notice we have opposites and hypotenuse. That's sine. Sine theta equals opposites over hypotenuse. And so it's a pretty easy solve. If I want to find theta, I'm going to do an inverse sine. Use your calculator. Inverse sine 16 over 40. 23.6. Theta is 23.6 degrees. Okay, 23.6.